everyone, I hope you all are doing okay. So we're the group 1 and we're here to discuss the part B of the activity given last meeting. So without further ado, let's delve into the questions. Under the part B, we have this question number 6, which is to compare and contrast myoglobin and hemoglobin. We'll only give you a brief introductions of both myoglobin and hemoglobin. So both myoglobin and hemoglobin are oxygen-binding proteins that play vital roles in our body's ability to transport and store oxygen. Hemoglobin is mainly found in red blood cells, while myoglobin is found in muscle tissue. Although they both deal with oxygen, they have different structures and purposes that make them unique. After me, my other group mates will explore how these two proteins are built, how they work, and how they differ yet complement each other in maintaining oxygen balance in the body.
In this part, I'm going to explain the myoglobin structure. So myoglobin is a special protein found in our muscle, and its main job is to store oxygen. Our muscles need oxygen to work properly, especially when we move or exercise. Myoglobin is made up of one single chain, so it's called a monomeric protein. Inside this chain, there's a hemic group, which is like a tiny pocket that can hold one oxygen molecule. It has a small, round, and compact shape, making it easy to fit inside the muscle cells. What's really amazing about the myoglobin is that it holds oxygen very tightly. So when your muscle starts to run out of oxygen, like when you're running, lifting something heavy, or doing anything hard activity, um, myoglobin releases the stored oxygen to help your muscles keep working. So you can think of myoglobin as your muscle's backup oxygen tank, always ready to help when you need extra energy.
The structure of hemoglobin. On the other hand, hemoglobin has a much more complex structure. It is a tetrameric protein, which means it is made up of 4 subunits, 2 alpha chains and 2 beta chains. Each of these subunits has its own heme group, so one hemoglobin molecule can carry up to 4 oxygen molecules at a time. Hemoglobin is found inside the red blood cells, where it gives blood its red color. Its quaternary structure allows it to show cooperative building. Once more oxygen molecules binds it, becomes easier for the next oxygen molecules to attach. This property is essential for efficient oxygen transport from the lungs to body tissues.
So today I'm going to discuss about the functional difference of myoglobin and hemoglobin, where the myoglobin is found in muscle tissue, where it acts as an oxygen storage unit or facilitator of oxygen diffusion. Being a simpler protein with only a single oxygen binding site, on the other hand, the hemoglobin is found within the red blood cells. It is a chef oxygen transport unit, efficiently picking up oxygen in the lungs and delivering it to various tissue and organs throughout the body. In terms of their affinity, myoglobin has a high affinity, binding oxygen tightly and releasing it slowly, but the hemoglobin has a low affinity, but it can adjust its oxygen binding ability by cooperative binding. If we compare their oxygen binding curve, the myoglobin has a hyperbolic curve, but the hemoglobin has a sigmoidal curve, reflecting its cooperative nature. So that's all. Thank you.
Let's get started with comparison and conclusion. So, both hemoglobin and myoglobin are oxygen binding proteins, so they are related to oxygen. So, they are also essential for our survival. While hemoglobin delivers oxygen to tissues, ensuring every cell gets its vital oxygen supply, while myoglobin stores oxygen in muscles, acting like a reserve tank for when you need it the most. Okay. Though they're different in structure and function, but they complement with each other perfectly. So they respond to each other perfectly, and without one another, they cannot function very well. So they keep the oxygen supply steady whether you're resting or having a crushing workout. So in conclusion, these dynamic proteins ensure your body meets its oxygen needs efficiently, keeping you powered up and ready to go. They're the unsung heroes of your body's oxygen supply chain, working tirelessly and to keep you at your best. That's all for today. Thank you for listening.
So for question number 7, discuss the importance of proteins in human nutrition and what might happen if the diet lacks sufficient protein. So proteins are one of the most essential body needs to stay healthy and function properly. They play a major role in body growth, tissue repair, and the production of hormones and enzymes. So without enough protein in our body will not be able to repair itself and function properly.
For example, when we perform workouts or physical activities, our muscle fibers develop tiny tears. Proteins provide amino acids that help rebuild these micro tears, making the muscle stronger and larger over time. This shows how important protein is in supporting physical strength and body development.
Aside from muscle growth, proteins also help regulate and maintain various body functions. They contribute to the structure, function, and regulation of the body's tissues and organs. Proteins are also responsible for producing enzymes and hormones that control many processes in the body.
However, lacking sufficient protein intake can lead to serious health complications such as muscle weakness, edema, anemia, and even organ malfunction. When our body doesn't get enough protein, it becomes weak and more prone to diseases and illnesses that can be dangerous and life-threatening.
In summary, proteins are vital nutrients that supports body growth, tissue repair, hormone and enzyme production, immune defense, and energy supply. Having enough proteins help maintain strength, support body function, and prevents malnutrition. Therefore, we must ensure a regular and balanced intake of proteins to stay healthy, strong, and well nourished.
Last question. Enzymes are proteins that act as catalysts. Give an example of an enzyme and explain how it works in the body.
So number one, amylase. Salivary pancreatic. Amylase is the body starting enzyme that found in saliva. And in pancreatic juice in the breaks starts into simple sugar like maltose inserting the mouth and as finishing the small intestine. It works based in mild pH and low activity can cause for start, desiccation, and bloating.
Is lipase, or pancreatic and gastric. Lipase digests fats by breaking triglycerides into fatty acids and glycerol, with bile helping emulsifies fats for faster action. Low lipase or bile problems cause fatty stools and poor absorption of fat-soluble vitamins like A, D, E, and K. Next is pepsin, or the stomach. Pepsin, activated by stomach acid from pepsinogen, breaks proteins into peptides for further digestion. It needs a highly acidic environment. Low acid reduces protein digestion efficiency.
Okay, next we have the lactase. It is found in the small intestine. Lactase breaks down lactose, or milk sugar, into glucose and galactose for absorption. Low lactase level causes lactose intolerance leading to gas, cramps, and diarrhea.
For the last example, we have catalase, a cellular enzyme that protects cells by converting hydrogen peroxide into water and oxygen, thus preventing oxidative damage, especially in high metabolism tissue. So as we can see, enzymes are tiny, but their impact is truly enormous. They break down the food we eat, fuel our energy, and protect our cells from harm. They are the small wonders that keep life moving and health thriving. That is all for our report today, and we do hope that you guys have learned something. That's all. Thank you.